convert to polar coordinates. So what am I telling you then? If I say convert to polar coordinates, what is this -1? Is it an r, a theta, an x, or a y? It's an x value, because that means, okay, if we're converting to polar coordinates, that means we're going to be in rectangular coordinates. Is that clear? All right, so what do we need? We need r and theta, right? But I like what you said. You told me a relationship that's important. You told me that r squared is equal to x squared plus y squared. And that will get me r. I can use that to get r, right? Because I know x and y. So you have to know what you have in order to figure out how to get what you want. So fill it in for me. What's r squared equal to? 2. Yeah, because you get -1 squared, that's x, right, squared, plus 1 squared, which is 2. So what's r? 2. Yeah, now technically, if you wanted to do it in some crazy way, you could take r to be, I suppose, -√2, right? But don't. I mean, there's no reason to. Keep it simple. All right, so what else do I need?
You need theta.
I need theta. So what's the relationship between x and y and theta?
It's a tangent.
Okay, so tangent of theta equals what?
Y over -1.
Yeah, so it'd be y over x, which would be 1 over -1. So you get tangent of theta is equal to -1, but you better be careful, because especially if you're relying on your calculator. Let's switch. Let's be in degree mode just for fun, because we were in radian mode earlier. What would your calculator spit out? Now this is something you should know, by the way, without the calculator. But if you were relying on your calculator, what would your calculator spit out for theta? What would you do to both sides? Take the tangent inverse. So you take the tangent inverse of -1. And what angle would your calculator spit out? It would spit. No. It would spit out negative something, because the tangent inverse is defined in which 2 quadrants? First and fourth. Tangent, you're thinking of where tangent's positive, but we need 2 quadrants where it's negative to make the inverse function make sense. So it's one quadrant negative, 1 quadrant positive. So we take the first and fourth quadrants for the basically the range of the tangent inverse. And it's going to spit out -45 degrees, right? But
meaning theta is 7 pi-4.
But it's not, because if you actually graph this point, you'd go which direction to the left or right? You'd go left 1, right?
Oh, so
And up 1. It'd be in the second quadrant. So really, the way you want to think about it is reference angles, once again, especially if you're not dealing with nice numbers. So the reference angle would be just 45 degrees. Right? And you can get that without a calculator. You should be able to get that without a calculator. You should know that. Just delete the negative on the 1. You should know the tangent of 45 is equal to 1, right? So alpha, the reference angle is 45 degrees. In the second quadrant, what do you do to find theta? You take the straight angle minus 45. So what do we get? 135. Okay, so what's the point? So you do r comma theta, so √2, 135 would be one representation of it. X equals -4. We don't have a whole lot of choices here, right? So we want to convert. This is what coordinate system is this in?
Rectangular.
And by the way, what is it? It graphs to be what?
Vertical.
A vertical line at a horizontal position of -4, right? That's nice to keep in mind. And it's actually a very simple equation, isn't it? X equals -4. Let's switch to polar and see if we get a more complicated equation or less complicated equation. So we don't have much of a choice here. What is x in polar coordinates? Yeah. So r cosine theta is equal to -4. It doesn't look simpler to me. But sometimes equations that have, especially ones that have radial symmetry, like circles, are simpler in polar coordinates. This one is not. So what might we do to irritate you here? Actually, it's not to irritate you. your calculator has a polar mode. And the only way you can type in equations is if you solve them for r. Because it's like, you know how in rectangular coordinates it's y1 equals whatever. In polar coordinates it's like r1 equals something in terms of theta. So you need to be able to solve these things for r. So we do that. We divide both sides by cosine theta. And you get negative 4 over cosine theta. What's a nice way to write that? So r equals negative 4 over cosine theta. What's a nice way to write that? Negative 4 times secant theta. There's more trig review for you, right? 1 over cosine theta is secant theta. So that would be a nice way to write it. Now, if you were going to plug it in your calculator, though, you'd have to type it in as negative 4 divided by cosine theta. All right, now the temptation might be to divide through by y here to make it a simpler equation. I wouldn't do that. You might lose, well, you'll lose the solution where y equals 0. So be careful when you do that. If you're in doubt, don't divide through by a function or a letter if you're ever in doubt. So let's just do the conversion then. What's y equal to in polar?
R sine theta.
So let's just replace y with r sine theta in both y squared and the 4y.
So it'd be R sine theta quantity squared.
Yeah. So we could make it on the left side r sine theta in parentheses, the whole thing squared, and then equals 4 times r sine theta. And then how could we rewrite that? Just
R squared sine squared theta.
r squared sine squared theta equals 4r sine theta. Now you can just leave the answer like this if you want.